Sathyabama Institute of Science and Technology.
Dear learners, welcome you all for the Fundamentals of Stoichiometry Module 2. This module, we will discuss about the conversion and yield. As in the previous modules, we are discussing about the moles, molecular mass, molecular formula, mass basis to weight basis conversions. So in this module, we are discussing more about how the reaction takes place and how we will calculate the yield and conversion for the particular reaction. So we say when we are in a stoichiometric reaction, that is nothing but the balanced reaction where the reactants is converted into products. So when we term the conversion is nothing but the fractional or percentage changes from the reactants to the products, and yield, how much product we are getting from the conversion. And selectivity, it is based on when we are saying multiple compounds are formed, we want to know what is the selectivity of that yield particular compound, that is nothing but your desired compound. So when the reaction is happened, we will get products, byproducts. So the product is your desired product. So when we are having a discussion about conversion is nothing but amount of the reactant consumed divided by the initial amount of the reactant fed. Yield is the moles of product formed divided by the moles of reactant fed. So when we discuss about in the earlier slides, we will have reactants and converted into products. In that, there are two particular terms, limited reactant and excess reactant. Limited reactant are the rate determining steps. If the chemical reactions proceed in the completions, there are particular amount of species react first and it will be present in the quantity completely consumed. This is the rate determining step. That reactants are called as limited reactant. When we say excess reactant, the species or the substances which is present again from the stoichiometric ratios or stoichiometric quantity, that is said to be excess reactant. How much extent the reaction will be happen, that will be calculated by the extent of reactions. The maximum extent that reactants are converted into products. So we will have a formulas for that calculating the conversion and yield. Percentage conversion is nothing but moles of the limited reactant, because that limited reactant, if it is consumed fully, it will be converted into products. So that is that we will take moles of the limiting reactant that is fed into the reaction divided by the moles of limiting reactant fed initially into 100. Yield based on the feed, it is the amount of desired product divided by the amount of key reactant consumed. So yield based on the 100% conversion is nothing but amount of product obtained divided by amount of key reactant consumed. Already we will discuss in the module 1, moles is equal to weight by molecular weight, mole fraction is equal to moles of solute divided by total number of moles. So in this problem, we want to determine the limiting reactant. So take an example. Silicon nitride is very odd, high temperature resistant ceramics used for the turbine generations. It is prepared according to the following equation. 3 silicon plus 2 nitrogen gives Si3N4. From this, which is the limiting reactant when 2 grams of silicon and 1.5 grams of nitrogen is reacts? We have molecular weight of silicon 28, molecular weight of nitrogen N is 14 gram per gram mole. So they are given in mass basis, we want to convert into mole basis. So we know that moles is equal to weight by molecular weight. So moles is equal to weight 2 grams, molecular weight 28. So the moles of Si is 0.07. Mass of nitrogen is 1.5 and molecular weight is 14. So 1.5 divided by 14. So when we are having 2 nitrogen molecules, it's 28. 1.5 divided by 28 is 0.054 gram moles of nitrogen. Calculate the ratio of silicon and nitrogen. Silicon 0.07, nitrogen 0.054. That is making a ratio. So 1.3 is to 1. The ratio which is given is 2 is to 1.5. That is nothing but 3 is to 2. That is 1 is to 1.5 ratio. As per stoichiometric, 3 moles of silicon reacts with 2 moles of nitrogen. So 3 is to 2 is nothing but 1.5 is to 1. This is stoichiometric ratio. This is the ratio which is given. So 1.5 is to 1 and 1.3 is to 1. When we compare these two ratios, we see that the silicon here it is 1.5 as per stoichiometric, but actual we fed is 1.3. That means silicon is the limiting reactant. So how much moles of the product is formed? We will calculate based on the limiting reactant, that is nothing but Si. That is 3 moles of Si will give you 1 mole of Si3N4. That is 0.0307 gram mole silicon into 3 gram moles of silicon will give 1 gram mole of the product, that is equal to 0.0237 gram mole of Si3N4. You may calculate this Si3N4 based on nitrogen also, but when we calculate the yield will be lesser for the limited reactant, because limited reactant is the rate determining product. So similar way we have to calculate the excess reactant. Take an example, 316 gram of aluminum sulfide reacts with 493 grams of water. What is the mass of the excess reactant remains? So they are asking how much excess reactant which is available. Reaction Al2S3 plus 6H2O gives 2AlOH thrice plus 3H2S. We have to calculate again, moles is equal to weight by molecular weight. Al2S3 is 316 grams divided by the molecular weight of Al2S3 will give you 2.104 moles. 493 grams of water 493 grams divided by the molecular weight of water 18, that will give you 27.366 moles. 1 mole of Al2S3 will react with 6 moles of water molecule. So the stoichiometric ratio is 1:6. So the ratio what we are given and what the actual we fed into the reactor is 2.1:27.36. That is nothing but 1:13. Stoichiometric ratio 1:6, but the availability is 1:13. Which check it out, Al2S3 is a limiting reactant and water is the excess reactant. Actual requirement is 6, what we fed is 13. So water is the excess reactant. For 1 mole of Al2S3, 6 moles of water is required. That means 2.104 moles of Al2S3 requires 12.63 moles of water only. But we fed 27.366. So excess is nothing but 27.366 minus actual requirement 12.63, that is equal to 14.736 moles. Again the question is about what mass. So we want to convert mole basis into mass basis. So multiply by the molecular weight 14.736 into 18, that is 265.5 grams. To calculate the percentage excess, how much we fed 27.366, how much is required 12.63 divided by 12.63 into 100, we are given 116% excess of water. So this next we want to calculate the yield. Take this problem as an example. 950 grams of copper sulfate are reacted with 460 grams of zinc metal. So what is the theoretical yield of copper? If 295.8 grams of copper are actually obtained from this reaction, what is the percentage yield they are asking? So the reaction is CuSO4 plus zinc will give you zinc sulfate ZnSO4 plus Cu. So we want to calculate the moles. Mass is given 950 grams divided by the molecular weight will give you the moles of copper sulfate. Similarly, zinc, the mass is given 460 divided by molecular weight of zinc, you will get the moles of zinc. So when we check it out, the ratio 1 moles of copper sulfate will give you need 1 moles of zinc. That means 5.95 moles of copper sulfate required, 5.9 moles of zinc alone. But we are supplied 7.03 moles. That means zinc in excess and CuSO4 is the limiting. So we want to calculate the product formed. 1 moles of copper sulfate react with 1 moles of zinc will form 1 moles of zinc sulfate and 1 moles of copper. That is 5.95 moles of copper sulfate will produce 5.95 moles of copper. So the mass of product formed is 5.95 moles. So multiply by the molecular weight, you will get the mass of copper formed. So the mass of copper formed is 378.2 grams. That is the first question. What is the theoretical yield of copper? The theoretical yield of copper is 378.2. The second question, if the product is 295.8, that means theoretical yield is 378 grams, actual yield they are given in the problem is 295. So 295.8 divided by 378.2, that is given 78.21% is the yield. So we will discuss what is limited reactant, what is excess reactant, how to calculate the yield. Now we are going to calculate the conversion. So for this reaction, 14.4 kg of carbon dioxide are formed in the reaction of 10 kg of C7H16, what is the percentage conversion of C7H16 to convert to carbon dioxide? Again, you have to write the balanced equation. C7H16 plus 11O2 gives 7 carbon dioxide plus 8 water molecule. So that is 1 mole of C7H16 reacts with 11 moles of oxygen, gives 7 moles of carbon dioxide and 8 moles of water. They are given in mass basis. Convert into moles. Moles is equal to weight by molecular weight, that is 14.4 kg of carbon dioxide divided by 44 kg per kilomole. 1 mole of C7H16 required 11 moles and it will produce 7 moles of carbon dioxide. So 7 moles of carbon dioxide is produced for 1 kilomole of C7H16, that is equal to 0.0468. Similarly, you have to calculate others, and the percentage conversion is how much is reacted, that is 0.0468 moles reacted divided by C7H16 is fed. How much C7H16 is fed? 10 kg. So 10 divided by the molecular weight, that is a quantity of C7H16 fed. So into 100 will give you 46.8% is converted. So in this lecture we discussed what is chemical reaction, what are reactants, what are products, byproducts, what is desired products, and how we have to calculate the limited reactant, excess reactant, how to calculate the conversion and how to calculate the yield. So for any queries, contact satish.chemical@sathyabama.ac.in. Thank you.